There we go.
Thank you for pointing that out. All right, so welcome to the Cleantech Meetup. Go ahead and click to the next slide. All right, so CleanStart is a nonprofit that's organized to turn Sacramento into a clean tech hub, really the greater Sacramento area. It was founded by Gary Simon and Mark Henwood in 2005, and I'm Thomas Hall, the executive director. Next slide. All right, so the topic of this Cleantech Meetup is electrification. Now that seems really broad, and it kind of is, but it's very, very important. There's a lot of things that we do that are not necessarily electrified. One of the common ones that's moving more towards electrification is, yard care, weed whackers, lawn mowers. Those are becoming electrified, and there's also building electrification. And it's a big part of where we're going as a society to fight climate change and to live a little bit more sustainably. Next slide. All right, first I want to thank CleanStart sponsors, the College of Engineering and Computer Science, SMUD, Blue Tech Valley, and Weintraub Tobin. I think I saw Dean Smith enter the room. How are you doing, Dean Smith?
Very well, very well.
Excellent. Well, welcome to our Digital Cleantech Meetup.
Thank you, Thomas.
Right. Excellent. And on to the next slide. So here's our agenda for the evening. I'm going to have some reminders about how we're going to handle a virtual meeting, announcements, and then we're going to start with PHIXED, NLine Energy, Simpl Energy, Building Decarbonization Coalition, and then we're going to have kind of a wrap up where we can sit around and talk and hopefully do some networking. All right, next slide. So the reminders is pay attention to your mute button. Use the raise hand. Go ahead and put questions in the chat. I have Asado who's collecting questions to make sure that we get all of them and that we can get them answered in the most timely way possible. Next slide. All right, now for the announcements. CleanStart's been putting on weekly to-dos, anywhere from 1 to 3 of them a week. These are short half-hour talks where we discuss, the future of clean tech, where companies are going, and what people can be doing to stay active right now. Next week, we will have CleanStart speak on the 4th, which is Thursday, about the projects they're doing. Now, if you're not familiar with CleanStart, they're about pushing clean mobility in California.
Yeah, that's CalStart. You said CleanStart, but it's CalStart.
Oh, force of habit, force of habit.
Yeah, really.
Right.
But
yeah.
We'll have Thomas Padham talking about that next week.
And I think I saw Thomas come in here too. Also, we'll have Pacific Fleet Charging on the 5th, talking about what they've been up to. And we're excited to have Julia Burrows on the 12th. That's 2 Fridays from now. And she's going to be talking about what the city of Sacramento is doing around climate change and innovation. So make sure that you sign up for that one. Also, we have a really strong community here. Startup SAC, they put on 1 million cups. Actually, it's more than just Startup SAC. They have a whole group of them that put it on, which is where startups can go and kind of not really pitch their ideas, but share their ideas and get feedback from the startup community. I know, Lisa, have you pitched at 1 million cups? Was it good?
I haven't personally pitched at 1 million cups, but the startup I was with previously, Chromatoscope, did, and we found the feedback to be very helpful.
Excellent. There's also office hours on June 4th, which I highly recommend you go and sign up for if you're looking to get support. It's by Josh, a habitual helper and habitual supporter of entrepreneurs in the ecosystem, and he has a wide network you can pull from. Additionally, Sac State Carlson Center has their Entrepreneurship Toolkit series going on right now. So if you follow that link there, you can go and sign up for it and stay connected that way. Additionally, there's a lot of business support that I want to point your attention to. One of them, Blue Tech Valley. This is actually a link to their events calendars. One of the things that they've started doing is a whole lot more virtual events. So if you want to learn everything from marketing to, they have a whole bunch of just business classes that I really want you to go click and check them out. There's ones all next week. I think I saw Jeff Macon. Anything you want to say about them, Jeff Macon?
Hey, Thomas. Yeah, this is Jeff Macon from Blue Tech Valley. And just thank you for the shout out. happy to be part of this program with CleanStart. And yeah, we try to help clean technologies commercialize and develop business in California. And by all means, check out bluetechvalley.org if you'd like to find out some more and get in contact with us.
Okay. Also, Moss Adams and Weintraub Tobin have had an actively updated COVID-19 support page. That's where you can find out about PPP, the CARES Act, and more resources out there to help your business get through this tough time. Additionally, when I said I was doing electrification to Leroy, SMUD has a whole lot of support for electrification because it's one of the big things that they see that can make an impact in communities with air quality and in climate change. So you can go and check out SMUD's Energy and Research and Development there, along with SMUD's Go Electric campaign. They have an economic studies for buildings and low-rise residential. And later at the end of this, I'll be sharing a video that Leroy shared with us. All right, next page. If you're wondering how to keep on top of this, connect with us socially. Connect with our email list, LinkedIn, Facebook, YouTube, Instagram. We now have Sarinjay here who's helping us with our Instagram, our website, which has routinely updated blogs and videos, and Empower. If you're a clean tech company, I suggest you click on this last one here, that little plug with some leaves on it, and sign up for Empower. That's how you can network, so you can go after a lot of the CEC grants that you've probably heard about, EPIC funding, and so forth. Also, if you click on that Startup SAC there, it'll take you to sign up for the Startup SAC newsletter, which is one of the best ways to stay connected. All right, next.
And Laura's put a link in chat for office hours with Josh David Miller. I don't know whether Josh is on the call or not, but Laura, do you want to say a sentence about that? You might be on mute. Okay, maybe we lost Laura.
Yeah, no, I'm here.
Okay.
So Josh works for a company called Mindbox, and they help all sizes of companies, work on strategy. But for this one, Josh is going to discuss the mantra of survive and thrive during the pandemic. So he'll be talking about what innovation is, how you can think about your business as a model that can be tweaked to create many interesting hypotheses of things to try. So I think it's going to be really good. I encourage you guys to join us.
Well, that's great. Appreciate it. Also, I see Steve Gadiri has joined us. You had the best attendance record when we were doing this live, Steve. So it's nice to have you back virtually.
Thank you, Gary. I'm missing you guys.
Yeah, likewise.
Excellent. I'm going to put a link to these slides again because everything in here is hyperlinked out, so you can learn more about kind of what's going on. And I wanted to say congratulations. Last week was the Big Bang competition, and they announced 2 winners. And there's a CleanStart Award and the Energy Award. SMUD's sponsored the Energy Award, which Pacific Fleet Charging, who will be doing it to do next week, won. Congratulations, yay.
Hey.
Here's a video. Bill, do you want to hear yourself talk?
I try to avoid that whenever possible, Thomas.
All right, well, if you're interested, follow the link and you can check out the video that helped them win that Big Bang prize. Also, Fixed Systems won the CleanStart Award, which is sponsored by Gary and CleanStart. Congratulations, Lisa, and your entire team. And with that, let's click to the next slide. A transition into welcoming Lisa Isles, founder of Fixed.
Yeah, you got an N in there. It's Fixed, and I don't think Lisa has much to do with electrification except indirectly, but we wanted to give her a chance to get a real pat on the back from everybody. So Lisa, tell us a little bit about what Fixed has done and where you're going to go from here.
Sure. I actually have a couple slides that we could go through just to give people some additional context. I'd be curious to see if anybody could come up with electrification applications. I haven't, but there are definitely quite a few clean tech applications for our technology. Well, it looks like the host has disabled screen sharing though.
I am getting that set for you.
Yeah, well, you're dealing with hydrogen ions, so that's close enough to being electrified.
I'll take it.
That's good.
All right, let's see. Still disabled.
Yeah.
Oh, something changed.
There you go. Okay.
Still disabled. Let's see. Maybe I should leave and come back.
Nope. Go for it.
Oh, there we go. Yay. Thank you. All right. I think
All right,
everybody
here we
should be
go.
able to see that now. Hi, everyone. I'm Lisa. I'm the CEO and founder of PHIXED Systems, and PHIXED is a sensor startup that is working on predictive analytics for biomanufacturing. I was thinking I would tell you a little bit briefly with some fun pictures about what we're doing as a company, and then you can ask me whatever questions you have about PHIXED. I also stuck some clean tech and green tech applications of our technology in just to provide people with some additional context. But briefly, PHIXED will disrupt biomanufacturing by being the first to leverage sensor integration and predictive analytics to decrease manufacturing costs. So ultimately what we're looking to do is essentially help companies predict failures before they happen and increase process efficiency. So biomanufacturing generates about $140 billion in annual revenue each year in just the United States. Biomanufacturing isn't really a common way of describing a set of industries, but at a high level, biomanufacturing produces life-saving medications, nutrient-rich foods, critical industrial chemicals, and some of my favorite cheese. Examples of biomanufacturing organizations in our area include Genentech, Dow Chemical, and Budweiser. So the industry is also experiencing a lot of really exciting growth and change, especially focused on environmental and sort of clean tech technologies more broadly. Impossible Foods is one that I like to point to a lot because basically what they're doing is they're creating, I'm sure everybody's heard of this, but in case you haven't, Impossible Foods is basically creating a beef substitute using plant sources instead of animal sources, but it's a product that's pretty chemically identical to beef. Novo Nutrients is a startup that is working on fixing carbon dioxide, so taking carbon dioxide from the atmosphere and converting that into animal feed. That's also kind of a clean tech type startup. And then because there's a pandemic, I also just like to throw in Moderna. Moderna Therapeutics is a company that is actually working on an mRNA vaccine for COVID-19. So that's a new vaccine technology that we're seeing. And all of these exciting changes are great, but there's kind of a problem, which is that the sensor technology used to monitor the biomanufacturing process that produces all of these new and exciting products is extremely outdated. I stuck a sensor up here, so like the sensor transmission system really up here. As you can see, it hasn't really been updated since the 1980s. And this turns out to be a huge problem. So an estimated 10% of all biomanufacturing production runs fail due to bad measurements. So in the United States, this translates to a $14 billion annual loss. So this is where PHIXED comes in. PHIXED has developed a platform technology that can detect issues within a biomanufacturing production run before they ruin the product. Basically, we do that by using sensor integration technology and predictive analytics. That's some patented technology that we've developed. And the first product we have is the pH subsystem. What the pH subsystem does is it takes multiple pH measurement inputs and then uses sensor integration to predict when a particular biomanufacturing run might fail, and also provides the biomanufacturing company with unique insights about how their product and production run is doing. So the pH monitoring market we chose to target because it's actually one of the bigger sensor markets. It produces about $1 billion in value each year, and the platform technology has a market potential of about $13 billion. And so lastly, I just wanted to tell you a little bit about some fun applications in clean tech and green tech. We have an image here. Oh, there we go. So does anybody know about the UC Davis biodigester? Maybe not.
Just
Great.
talked about it last time.
Oh, nice. So that's actually in my department. So that's my department's claim to fame. So I'm glad people know about it. But we did some math the other day, and implementing PHIXED technology would allow the biodigester to improve its efficiency by 10%. So that would be really exciting because we could make more biogas with the same amount of compost, essentially. Looking at some other projections here, Novo Nutrients, which is a startup I mentioned earlier that's focused on fixing carbon dioxide, so taking it out of the atmosphere and then turning it into animal feed. Once they scale production, and if they were to implement the PHIXED system, they would generate an estimated $50 million in savings each year and sequester an additional 22 tons of carbon. So with that, I just wanted to say thank you so much to Gary Simon and CleanStart for your support. This award means a lot to us. We're moving forward with this money to get some additional intellectual property protection in place before we work with the National Science Foundation this summer. And it also allows us to continue to prototype despite the COVID pandemic. So thank you. Happy to
Well,
take
thanks for-
questions if anybody
Thanks for
has
joining
any.
the Big Bang, and thanks for sticking it out through the whole thing. I know it was a bit of a process, particularly having to do everything virtually. But,
Yeah, definitely.
we're very, very happy to have given you the award this year. So
Thank
any
you.
questions before we let Lisa go?
I have a question. So Lisa, on the biogas facility in Davis, so what does your sensor allow, or what processes does that allow the operators to tweak?
So
Yeah, can you explain a little bit?
yeah, so the biodigester uses bacteria fermentation processes to generate biogas. And one of the problems that they've encountered frequently is there is a pH range at which the bacteria produces biogas optimally, and that if they're able to actually measure that pH more accurately, ultimately what that lets us do is that keeps the bacteria happier and allows them to produce more biogas with the same amount of input.
So, like, for example, they might put more something in, like,
Yeah, more base, for example. Oftentimes what you see with these sensors is that they're connected to a control system. And this control system would either dump acid or base into the fermentation to keep the pH at a specific level. The problem you encounter almost universally is that pH especially is a notoriously unreliable measurement. And so what that means is you're basically lying to the control system, and the control system is actually adding additional acid and base into this fermentation that oftentimes actually damages the productivity of the bacteria in this case.
So I think this is a good application for dairy digesters as well.
Yeah. Mm-hmm. That's something we've looked into.
They're not very efficient. I mean, it seems like they could use a lot of help.
Yeah. Biopharmaceuticals is also one where you see quite a bit of this. And what's interesting, even though that's not necessarily a direct clean tech application, it's really expensive to dump out these batches, and the amount of resource that goes into producing the media for the cells that are super sensitive, that are often producing these complex molecules, end up being just kind of ridiculous. So there you can see losses of upwards of like $6 million each time you lose a production run.
Wow. Thanks.
So
Yeah.
CleanStart gave Professor Zhang the Cleantech Innovator of the Year award on that system, I think in 2008 or 2009. So
Yeah, she told me about that.
we really like the system over there, and congratulations for taking this next step. So with that, I think we'll move on, Thomas, to our first speaker.
Sounds good.
Thanks so much, Lisa.
Yeah, thank you for having me.
All right. So. All right, there we go. So on to our next speaker, which is, well, 1 second, everything's in front of my screen.
Yeah, so
I'll just stick to this while we're going forward, just move forward one at a time. But in a nutshell, NLine Energy has two business groups, and what we focus on is capturing renewable energy in the form of harnessing wasted pressure in existing water pipelines, primarily for irrigation districts and water agencies, and converting that wasted pressure, typically at a pressure reduction valve, into renewable power, and either using that power to offset on-site electricity or to sell that to the existing utility. So I guess in our electrification form of things, we're trying to electrify existing water pipelines and conduits. And the other portion, division of our business, focuses on the thermal energy recovery side of things in the form of harnessing excess pressure from steam, typically at boiler plants, lumber facilities, and hospitals where boilers are generating excess steam in the form of pressure. And they're typically having to drop that down to a certain pressure using pressure reduction valves so it's usable in their systems. We have developed 91% of the small scale hydroelectric projects in California, and we say that humbly. It's been a long process to get there. Company was started in 2010 by our CEO named Matt Swindle. He's a lieutenant colonel in the Marines. And at the time, he was working for a company named Enernoc. And Enernoc works on demand response for water agencies and local utilities. And what that means is they were looking at time of use rates and how to use their pumping, their treatment, their RO type equipment more efficiently to avoid large power prices. And he was touring a water system and came across, it's called a pressure reduction valve within an existing 24-inch pipeline. And he asked the guy, "What is this?" And the guy said, the operator says, this valve, within this pipeline, we have drinking water, and it's cutting the pressure from about 100 PSI, pounds per square inch, down to about 30 pounds per square inch. So when it comes out in your shower at home, it's not breaking your skin. And he said it was one of the loudest, most inefficient type of units he's seen. And it was dissipating that pressure in the form of sound and heat energy. And so he thought, well, there may be an opportunity in this to install a hydroelectric style turbines in parallel to existing pressure reduction valves that essentially mimic the same function, but operate in tandem with one another to allow water operations to be the primary goal and power production as the secondary goal. So I'll move forward to the next slide. So just to put it in context for you guys, we typically work on projects sub 5 megawatt, and even more so primarily on projects sub 1 megawatt. And just for a little bit more context, 1 megawatt is enough power to supply energy to about 500 to 800 homes. So we're not working on large dams. We're not working on a Folsom Dam, a Bonneville Dam, where you're empowering an entire region. But we are working on opportunities that exist within existing infrastructure, and you build up enough of these projects and it starts to make a real impact in local communities. The value of small hydro, and one of the things we've tried to work on with a lot of our clients with the water agencies and irrigation districts is the technology has been around for a long time. The Pelton wheel, which is one type of technology, was developed in the 1800s, has a proven asset life. And just a little bit of background for you guys, a little bit what NLine does. It's probably easier to tell you what we don't do. We're not a general contractor and we're not a turbine manufacturer, but we do everything else in between to provide a turnkey solution to put projects in the ground in typically a 2 to 3 year process, or typically a 2 to 3 year timeline. We've identified a process to do that. So our team is project managers, civil engineers, mechanical engineers, electrical engineers. We also perform we help find grants for projects. We help find subsidies. We perform engineering services during construction. We stamp drawings. We start up and commission projects. We train operators, and then we cut the cord at that point at which the client owns the project and runs it afterward. So that being said, we've identified a process, and in California, we've had a lot of success because, believe it or not, the regulatory hurdles have been in favor of sub 5 megawatt in conduit hydroelectric projects. The larger dam type projects, your 10, your 40 megawatt projects, typically involve a 5 to 10 year licensing and regulatory process, whereas, like I mentioned, our projects typically are 2 to 3 years. And they're pretty minimal in terms of maintenance, which is why the operators that we work with like these projects. Next slide. There we go. This is just, I'm just going to brush over this. This is just a simple diagram of kind of the concept of one of these projects. So you have an existing pipeline, and we implement a hydroelectric style turbine generator in parallel to the existing bypass, of which you'd have a pressure reduction valve. And that data gets sent to a programming logic controller, which helps regulate and govern the water system based on demand. So water delivery is always the first priority, and the turbine operates in parallel with an existing valve and bypass. So if there's ever an outage, if there's ever power type issues or hydraulic, electronic control issues, operators are notified through a web-based portal. They receive an alarm and alert on their phone or in their SCADA system through their water operations. A valve shuts to prevent flow running through the turbine, allows water to keep running through the existing bypass valve, and it allows time for operators to get on site and address any maintenance type issues with the hydroelectric system. So I'm almost wrapped up here. There's a couple more slides. The type of sites that we work on and identify, there's typically a couple different classifications. One that we call our high pressure, low flow sites, and one that we call our low pressure, high flow sites. So for on the first category, it typically involves pipelines between 8 and about 60 inches that are flowing at least 3 cubic feet per second or 1,500 gallons per minute. And water's running through that pipeline, and a pressure reduction valve is then dissipating at least 40 pounds per square inch across that valve prior to its downstream location. And the idea there is we tie in on the high pressure side of that pressure reduction valve, install a hydroelectric powerhouse in parallel to that valve, and then tie back in with a pipeline downstream of that existing valve so they can operate in tandem. The other major classification on the low head, high flow sites, think of irrigation canals, check structures, weirs, or what we call low head dams. So drops of anywhere between 10 and 25 feet where you have flows larger than 300 cubic feet per second. And that warrants a different array of technologies that we can implement. We work with over 30 different turbine manufacturers to help find the most appropriate fit and most cost-effective fit for the site. So we serve as an extension of staff for existing water agencies to implement these projects in a turnkey solution, so they know they're getting the most optimal turbine for what type of project that they have and their hydraulic conditions. I'll show you a couple quick example projects here. This project was done for the Fontana Water Company in Southern California. It's the Sand Hill Water Treatment Plant project. They had a 30-inch raw water line, which you could see on the far right in the upper right corner. That's an existing pipeline, and there's a pressure reduction valve on that pipeline. And they're delivering raw water into their water treatment tanks, coming in at about 277 to about 350 feet of pressure is being dissipated. So we tied in, implemented 2 pump-as turbines, which you're seeing on the left. Those operate in tandem with the existing valve, and we're just capturing wasted pressure at an already at a location with already pre-disturbed earth at a water treatment plant facility. Typically, our projects don't require any subsidies or grants or special loans, but we have been successful. As you can see on this project, we attained $848,000 in subsidies for the water agency because they were able to capitalize on a 30% investment tax credit, a 1% energy loan through the California Energy Commission, because there are favorable loans and subsidies out there for renewable small-scale hydropower projects, as well as, I'll show you another project where we were able to attain some funding, but I'll move forward to the next one. This project that we completed for the Mojave Water Agency is called their Deep Creek Hydroelectric Project. This is a Pelton-style turbine, so it's different than what you saw earlier in a pump-as turbine technology. What resonated on this project, you could find some press about it online. Mojave Water Agency came out and said, this building is about 24 by 30 feet in footprint, and it produces as much power as our 40-acre solar field. And that resonated, and that's been great marketing and PR for us. We commissioned that this last summer. Client's extremely happy with the project. They perform weekly check-ins and inspections, but the project pretty much runs itself. The last project showing you guys is at the B24 water treatment plant or water storage facility for the San Gabriel Valley Water Company. They have an existing high pressure line that's coming in at about 80 pounds per square inch, and they're reducing that pressure before water enters 2 1.5 million gallon tanks. On the downstream side of those tanks, they have 6 pumps on site that pump water out of those tanks based on demands in the drinking water system for people's homes. And so what this pump as turbine does, it allows the customer to offset some of the their pumping charges for those 6 pumps that are on site, which further helps improve their water infrastructure, and has actually been a huge role in their general rate case of preventing the increase in water rates for their users, because they're generating additional hydroelectric revenues, which mitigates some of their needs or mitigates some of their concerns in terms of funding and financing for improvements throughout an aging water infrastructure throughout their district. And that's all. I know I threw a whole ton of information at you guys, tried to do it in a condensed time frame, but I'll pause there, see if anyone has any questions, comments, etc.
So basically, Andrew, you're selling the package, the installed equipment. You're not doing a power generation as a service type model?
So what we're providing is a turnkey solution in terms of the engineering, the project management, speccing out turbine equipment, finding grants and financing for a project, managing projects through construction, and commissioning projects.
All right.
So
but
but
you're not owning any of the generation yourself and just selling the energy.
No, and that's a unique point, because I know on the solar side of things, they do have power purchase type contracts where it's a little bit easier to go under the owner lease type model. Whereas on the hydroelectric side of things, it's harder for us as a private company to come into a public water agency and say, hey, we want to own infrastructure.
Yeah, good point.
Because water agencies need to have complete control over their valves and water moving through their infrastructure. And for a leaseback type PPA ownership, your fuel source is whether those valves are open. Putting it in solar terms, your fuel source is the sun, right? That's something that's uncontrollable.
So do you have any projects that you're looking at in the Sacramento area from up in the foothills across the valley?
We've commissioned a project for the Amador Water Agency and a couple projects for El Dorado Irrigation District. We've installed over 10 projects. I just showed you guys 3 quick examples. But if you have any water agencies or districts in mind that have existing valves in their infrastructure that they want to take a look at, we're always happy to look at more projects in the area.
Great. Well, a few more questions. I mean, we'll come back and do a little panel discussion. Will Brieger, you've had your hand up and we're glad to see you because we thought maybe you got the $10,000 check and left for Jamaica.
Right. So I was just curious whether this technology has been paired with storage at any of these projects, or could be in a helpful way.
That's an excellent question. And we actually looked at that for the San Gabriel Valley Water Company B24 project that I showed you a little bit earlier. And what it comes down to is, at the time, battery storage wasn't as cost effective. For it to make sense from an economical perspective, the time of use rates at your peak period, when you're able to sell your energy, compared to your off-peak period when you're storing your energy, that delta has to make sense to warrant the cost of buying battery equipment. And for this specific project, it just didn't make economic sense to do that.
Right.
But we would absolutely be interested in pairing up with battery storage on future projects if it warrants it.
Of course, you have the advantage in most of these water systems that water's flowing 24/7, maybe not at the same pressure, but it's not as intermittent as something like wind and solar.
Peter, you got your hand up there. You want to ask your question?
Oh, yeah, sure. I just wanted to say that I actually did some work on a NLine project for you guys. I did the Waterman.
Oh, no kidding.
Yeah, I had to prepare the little power system models for the project.
Very cool. I'm managing that one right now. We should
be
going into construction. Well, we were going into construction. Supposed to be now, but COVID kind of halted things for a little bit. So we're looking at pushing into construction later this year.
Okay, cool. Yeah, no, that's. I was amazed that the ISO wants models for generation even 500 kilowatts. They want a model, and I'm like, okay, well, that's good business for my consulting company. So. But yeah, no,
And
I think it's a brilliant idea. It's really really good. Thank you.
we have a
Brandon Rose.
question. 72 kW was the smallest unit you talked about. What's the smallest unit you think is feasible to put into a PRV vault?
That's an excellent question. So we actually got funded partially by the California Energy Commission on that project. We won a grant for $500,000 to try to come up with more modular, cost-effective ways of standardizing small hydro and not having so much customization, because customization drives up project costs. And so we actually were able to reduce the project cost on that B24 project by about $200,000 to $300,000 by coming up with standard building size, standard design inside the powerhouse, standard turbine type equipment, and some replicable features for future designs. In terms of the smallest kW you could use for a project, it really depends on your price of power in the area. So I listed out those specifications for minimum flow and pressure type requirements that might make sense to look at a project. And if you back calculate those, that'll kind of give you a kilowatt rating. But generally, if you have favorable power pricing or tariffs in the area, generally projects above 40 kilowatts may be worth taking a look at. But when we see projects less than 40 kilowatts, it probably doesn't make sense to bring NLine in to do that. It might make sense just as a private landowner or individual to implement something because you may be able to do it more cost effectively.
Okay, great.
Brandon Rose, you had a question?
Yeah, I was going to ask, we have a competitor come through their pressure reducing valve in the Sac Suburban Water District at their Antelope facility. But they couldn't get their costs down low enough to make it pencil out as an R&D project, let alone sort of commercial competitive scale. So what you were just talking about, what is your sort of levelized cost on your kilowatt hour production for some maybe a good and maybe a so-so site?
That is a good question. It depends on the site hydraulics that we're looking at. So in terms of specific levelized cost, I don't have that information for you offhand. Typically on our smaller facilities, we've been able to come up with a 16 by 12 prefabricated fiberglass building that comes shipped with electrical panels, control features. And we've been working hard with our panel suppliers and electrical programmers to come up with a standardized panel for sub 100 kilowatt and sub 500 kilowatt units to help bring down costs. One of the most expensive, two of the most expensive pieces of equipment in any of these projects are, one, the turbine and generator, and two, the panels and programming. So we've been trying to come up with standardized panels and programming to an extent, as well as trying to come up with working with some of our manufacturers to make more off-the-shelf type turbine units as opposed to custom units to help bring those costs down. So to get back to your question, it kind of just depends on what the site hydraulics are and what the lay of the land is. And then we could probably better tell you whether or not it's worth your time to pursue it or not.
All right. Thank you very much. Joseph,
Great job.
Yeah, great job.
Yeah, you got no worries about competing with Lisa Isles. That was great.
Appreciate that.
All right.
All right, stop sharing here.
Okay, so Joseph, can I bring our the slides back up? All right. So next up from Simpl Global is Farid. And
Hi, everyone.
hello, everyone.
So Farid, you've been through the wars and several companies, and Simpl Global sounds very interesting. So take it away and then tell us what Simpl Global is doing.
Sure, I'll be happy to. Thomas, are you going to drive or you want me to drive?
You can go ahead and drive. I just made you co-host.
Okay. Everybody see my screen?
I have to try sharing it one more time.
Okay.
So you can see my screen now?
Not
No,
up
tell you
yet.
what. If it doesn't work in a second, I'll just start sharing them for you.
Okay.
All right, here we go.
Oh, there it is.
Tell me when to go forward, when you're ready.
Go ahead and go forward. I'm Farid Dibachi, founder and CEO of Simpl Global. I appreciate Gary, Thomas, and Laura's effort to put this together. And thank you, Gary, for the invitation. Glad to be here. We are, ordinarily, I start a presentation like this with a description of the company and all the bells and whistles that go with it. But given the audience and really kind of the interest in technology and products, I decided to start with products instead. We make a product called Simpl Box, essentially 3 different sizes of energy storage units, each designed to fit underneath a solar panel. A 1.5 kilowatt hour unit, a 1 kilowatt hour unit, and a half a kilowatt hour unit. Each of them are designed, if you go to the next slide, are designed to fit underneath a solar panel. The idea being that solar is designed to be deployed 1 panel at a time, be it as a residential application, a commercial, industrial, or even a utility scale. And we could deploy energy storage with solar 1 panel at a time and deploy as much, as little as, or as many as we like to have it be scalable, have it be very easy to install, very easy to maintain and monitor and manage. For those of you that have experience with energy storage, you know that one of the most difficult steps in deploying energy storage, particularly in solar applications, is the whole design and installation, maintenance and operation part of it. And as you can tell by the name of the company, we delved into a path of simplifying that process with a product called Simpl Box. Go to the next slide, please. So the first question that a lot of folks ask me is why energy storage? We are, given that the audience here is really a panel of experts, I would just say that, as you know, solar generates electricity 3 to 5 hours a day. Utilities are tightening the purse string, if you will, and they're forcing customers to move into time of use rates. That usually means during the hours where solar is generating, the customer doesn't get as much credit. And then in the evening when they're using the energy, that's when they're charged sometime a significant premium. Now, I'm sorry?
I think there's just some background noise there.
A lot of folks complain about the utilities doing this, but utilities are really responding to their economics and their circumstances, particularly since solar is not a reliably steady source of energy. Giving full credit to customers for delivering that energy whenever they want under variable circumstances to the utility may not be a sustainable model, particularly as the ratio of solar to overall energy or overall power at any point in time changes. So energy storage is very quickly becoming a requirement. You can go to the next slide, please. I decided to put up a little chart of the rates. I believe these are either Southern California Edison or San Diego Gas and Electric. And you can see how the rates, if you look at the numbers up there, 5 and 6, the rates almost double in the hours of 4 p.m. to 9 p.m. during the summer months. And at a very kind of a quick glance, this is the opportunity for solar customers. Again, be it commercial or residential customers. The arbitrage value, the difference between the on-peak and off-peak is so significant in some of these utility territories that deploying energy storage with solar is really a requirement. Next slide, please. So the company was founded by me in 2018. We are engineers. We believe in the social and political and economic impact of energy worldwide, as well as in the US. We have developed 3 pieces of key technology in order to make Simpl a reality, which I will delve into a little bit more detail later. But one is how we control the power flow. We use the impedance variation in order to do that, as opposed to switches, to both reduce the cost and increase reliability. We use plastics that are engineered for use as part of an energy storage system, again, to reduce cost, increase reliability, and increase performance, particularly thermal performance. And we use Internet of Things, IoT technology that we developed specifically for renewable energy applications. These 3 pieces of technology is what took really the first year and 3 months of Simpl Global as a company to develop these fundamental pieces of technology. And the mission around this whole thing is to make it so energy storage is very easy. It's very simple. It's easy to build it. It's easy to deploy it, to commission it, to install it, to maintain it, and so on and so forth. Next slide, please. I want to hit those pieces of technology real quick. Again, I don't know how technical the audience is, but I wanted to emphasize that controlling energy flow between a solar panel during various hours of the day, a set of batteries at various state of charge that they might be at, and an inverter that is really responding to the customer's electricity requirements is really kind of the technology that we had to develop here. It's not I don't want to say it's difficult, but it just hasn't been done before. And most people that do this today use switches and relays to switch between different sources and users of electricity. So we developed a patent pending piece of technology, and it connects essentially the 3 pieces: a solar panel, a set of batteries, and an inverter that is an off-the-shelf inverter. And that was one of the important pieces of the mission that we put in front of ourselves, is that we ought to do this with off-the-shelf inverters. There's plenty of people that are out there with very cost-effective and efficient off-the-shelf inverters available. So that's kind of the first piece. And any of you that are interested in delving deeper in any of this, I'd be more than happy to discuss offline, or if you have quick questions about it. The second piece is, whenever you go from a supercomputer model to a bunch of PCs, you go from a mainframe to a PC, the management of going from a central to a distributed model, it becomes a very kind of a significant obstacle. We are saying that instead of deploying a big cabinet or a big container full of batteries, deploy batteries in a distributed model, one solar panel at a time. But making these disparate pieces of energy storage work together and work together seamlessly, and then report their activities to the user, the owner, the operator, really required that we develop some fault-tolerant ledger sharing type of technology in order to allow all boxes to see other boxes, their activities, and the customer / operator installer also see the overall activity level. And that requires some technology development, which we really borrowed quite a bit from the IoT space. And the third one, which is a little bit counterintuitive, a lot of folks think that with batteries, you'd like to put them in a space that is thermally conductive so you can get rid of the heat. The truth is, particularly with this application, you want to keep the heat away from the batteries. We're installing these underneath solar panels, which means the idea of putting them in a metal box is a non-starter. However, using plastics also has significant obstacles, given that you have temperature and flammability ratings that you have to adhere to. The strength of the material to carry the weight is very important. And of course, the material needs to be electrically and thermally insulated. And lastly, we need it for it to be sealed. These batteries can be submerged up to 1 meters underwater and continue to operate seamlessly. So those three pieces of technologies are the pieces that we have been focusing on and have now finally productized. If you go to the next slide. Where we are is we've completed the product. We have units operating. We have submitted our samples for UL certifications. This product will be UL 1973 certified. So we are now in the lab going through certification. We could be done as early as end of June, but it's decided to be a little bit more conservative and say end of July. We have manufacturing set up in a manufacturing facility in Nevada, and we're ready to ship these things out to customers as soon as the UL certification has been completed. Next slide, please. In terms of our business model, we sell our product through the typical solar installer, commercial and residential, and the distributors that they work with. So it's a very kind of a pre-existing distribution model that is in place. We obviously make money on the hardware itself, but we also have developed a significant suite of software applications for optimization of this, the management and optimization for the customers, and that is a business model that we intend on pursuing. Next slide, please. A lot of folks ask me about, how do you compare? Powerwall comes to mind, and LG product comes to mind, and so I decided to really kind of simplify it and put it in a simple table. We use lithium iron phosphate battery chemistry, which is inherently both from a structural and chemical and thermal is stable compared to lithium ion. I would not recommend using lithium ion batteries in a residential application. I think they're fine for automotive applications, but not for residential or even commercial building-based applications. Lithium iron phosphate is a safer choice. With a lot of our competition, you have to buy big chunks of battery, 10 to 13 on the residential, and typically 30 to 60 kilowatt hour minimum on the commercial side. With us, obviously, you can deploy energy storage in smaller chunks, half a kilowatt hour to 1.5 kilowatt hour. When you bring a new Simpl box in the vicinity of an existing Simpl box, it automatically pairs with it. The customer, the installer does not have to do a thing. And that was a piece of technology that we developed. There is no on-off button on this product. Again, developed around almost super simple-minded installation process. It installs underneath the solar panel, so there's no space that's required. No additional inverter is required. This product works with the inverter that is already there for in a solar field, in a solar application. Our installation cost as a consequence is close to zero, and our installed cost is approximately today on a quantity basis as low as $667, quickly going down to below 450 as the volume picks up. We offer a 10-year warranty for the product, and also offer an extension, a 10-year extension that goes with it. Again, I can get into that in more detail for whoever might be interested. Next slide, please.
All right.
That's, thank you for the time. And if you have any questions, I'm here now, or there's my email and my cell phone number.
We're going to hit you with some questions real quick.
Yeah, let me just interject here. So just to explain a little bit more, let's see if I'm right in this, but what you've worked on before, Farid, basically the Simpl box is equivalent to being installed between the solar panel and the inverter. So the MPP tracking is in the inverter, and you're essentially keeping the inverter in its happy place by smoothing out all the variations on the power coming out of the solar panel through the battery pack. And so that's part of your whole idea on making it simple. Do I have that right?
You have that right. Although the technology with Simpl box is a little different than what you and I had discussed while I was at JLM with the product PHIXED. What we do here, we actually have, under normal circumstances, when the solar panel is active and generating electricity, and some of it is going to the inverter MPPT algorithm sets the operating voltage, and our system steals some of the energy from the solar panel and puts it in the batteries without disturbing that voltage. And that's what I mean by impedance matching.
Right.
Into that some more. So we actually, instead of sitting between at JLM, the product PHIXED, we sat between the solar panel and the inverter. Here, our internal power conversion circuitry sits between the battery and the solar panel. The solar panel is connected directly to the inverter at all times, which means if all the energy in the solar panel is going into the batteries, then we do have to have an MPPT engine internally to handle that. So there is essentially two MPPT engines. One is the one that comes as part of the inverter, it's sunk cost, if you will. But there is another set of algorithms that run inside our box that essentially manages, in cases where all the energy that comes from the solar panel has to go to the inverter.
So do you need charge controller between the panel and the battery in this case, or is the impedance matching good enough for controlling the flow into the battery?
The impedance matching does the work. Yeah.
Okay. All right, so there are a number of other questions. We'll see how many we can get to here.
Dean Smith, you had a question? What is the size of the Simpl box?
Yeah, just the size of it, approximately.
A lot of this stuff, by the way, is also on our website, so feel free to go there with a lot more detailed information. A 1.5 kilowatt hour unit is 29 inches long, 2.5 inches thick, and about 7.5 inches wide. So the cross section of it is about 2.6 by 7.5 inches, and the length of it is close to 29 inches. Weighs about 32 pounds.
And Dick, would it be safe to assume that they answered your questions on MMP tracking and the inverter?
I'm sorry, I didn't hear the question well.
I was asking Dick Flask if his questions were around MMP tracking and the inverter had been answered.
Yes, they've been answered.
Okay, then Peter, you had your hand up.
Yeah, just a kind of a simple question. So will this device work with microinverters and string inverters, or only with microinverters?
It's designed to work with microinverters, with optimizers, such as solar edges optimizers, and string or even central inverters. When you go to string inverters, there are some limitations where essentially all the strings that are connected to that string inverter must have the same number of energy storage units attached to them, right? It needs to be balanced.
Okay. So, but I mean, so if you didn't have the same number of panels on each string, then you'd have to, one panel or whatever would have to have fewer, no storage unit then. So you had the same number of storage units. Is that what you're saying?
Yeah, well, typically, if you have multiple strings that are in parallel that go into one of the inputs of a string inverter, have the same number of solar panels. However, just to clarify, not every solar panel has to have an energy storage unit attached to it.
Okay.
So you could have, for example, a set of, let's say 12 panels, 12 panel strings go into one of the inputs of a string inverter, and you could decide that only 8 of those 12 panels in each string should have energy storage. As long as you say 8 with every string, you're fine.
Okay. All right.
Okay.
I think that answers my questions. Thank you.
And then we had a question on the temperature, because it does get hot on roofs and behind the solar panels. Usually that degrades battery performance. Then you were talking about thermally insulating boxes that you put this in. So how do you deal with the degradation of capacity of the battery at the temperatures that you would experience on the roof?
Degradation as a consequence of temperature is definitely there, and I don't want to somehow claim that we've overcome that physics issue. However, what we did is, one, the package, the box, is a 3mm thick piece of a derivative of Lexan, which is the same material that is used in aircraft windshields. And there is air pockets inside to thermally, in addition to the jacket itself, which is obviously a thermally insulated material, the air pockets inside further insulate from a temperature perspective, the outside to the batteries. We have found that during a 4 or 5 hour peak temperature, typical summer period, where the outside temperature underneath the solar panel could go from, let's say in the 70s in a summer morning, all the way up to 120 and back down to 70, we've found that we stay 10 to 15 degrees below the peak that the air is experiencing inside the unit. And that's thanks to the thermally, the air pocket that we've built into the material, and the material itself being thermally insulated.
Well, that's quite a difference. So, I mean, on the usual performance curve of a battery with temperature, 10 or 15 degrees makes a heck of a difference. So congratulations on that.
Thank you.
And we need to move on to Panama. There's some questions on integration with demand side management and does the system communicate with that? But I think we'll have to come back to those because we want to leave enough time. So thank you very much for a great explanation and a lot of evolution in the product, Farid. I recognize how much progress you've made on that in the last 5 years.
Thank you, Gary. Thanks for having me, everyone. Please feel free to send me your questions directly. I'll be happy to answer to the best of my ability.
Okay. So let's bring up Panama.
All right. Take it away, Panama.
Great. You guys see on the screen? You hear me okay?
Yeah, you've got the best title of the evening, so I think we get it.
Yeah, exactly. Any questions? So, if you space out the whole rest of the presentation, at least you got, the gist of it right here. So first of all, thank you to CleanStart for having me. I'm really honored. I've been a longtime fan, not a first-time caller with CleanStart. So really appreciate all the effort you guys put into the community and all the results that come out of it. So really honored to be here. Thank you very much. I was asked to talk about building electrification. So what I'm going to do is I'm just going to run through what's happening in California and then nationally and internationally on building electrification. What are some of the trends that are leading towards it? And then what can we expect moving forward for startups looking at breaking into the space? So I run an organization called the Building Decarbonization Coalition, and we're a coalition of utilities, manufacturers of heating equipment, design and construction community, local governments, and non-governmental organizations. And we all work together to try to completely eliminate emissions from the built environment. And so in July of last year, Berkeley became the first city in the United States and potentially the first city in the world to ban new natural gas hookups in any new construction happening across their city. A wave of other cities have followed them. And I'm going to talk about some of the trends that have led towards Berkeley and these other cities taking the action, and what are some of the other cities that are taking a look at this. So first of all, one area that's been coming out a lot more that we haven't had a good handle on is the impact of burning gas in our buildings on local air quality. You know, we've done a great job with power plants and controlling pollution from power plants. You know, NOx emissions are one of the leading causes of respiratory damaging pollution in the world. It's been regulated for about over 4 decades by the EPA. It can bring about asthma-like attacks in people without asthma, and people with asthma. It can be incredibly damaging, and it's one of the leading precursors to smog. And we've done a great job with power plants in California as we've gotten rid of our coal plants, we've gotten rid of a lot of our old dirty gas plants and gotten a lot of renewables online. We've been able to reduce NOx emissions pretty significantly for power plants, down to 18 tons a day. We don't have those same pollution controls on our appliances in our buildings, on our water heaters or space heaters, et cetera. And so what that means is that we burn about the same amount of gas in California, natural gas, in our power plants as we do in our buildings. But because of the lack of pollution control, we're producing about 6 to 7 times more smog-causing pollutants from our buildings than from our power plants, which is barely less than all of our cars in California combined. For those of you that live in the Sacramento region, this is looking at some of the major air districts across California. The dark green, the turtle green, the second bubble in each of these rows compares building emissions of NOx compared to light-duty passenger vehicles. And you see that in your territory, your buildings actually produce more NOx than all of the cars within the Sacramento Metropolitan Air Quality Management District. And they just took action actually around new CEQA thresholds for natural gas in new construction within their territory. And a new study that just came out from MIT just in February was, I think, really shocking to a number of us working in the space, and that it found that nationally and in California, that the burning of fossil fuel in buildings is now the leading cause of premature death from air pollution here in the state and in the country. I think a lot of times we think of it as trucks or cars here in California, but the proximity of the pollution sources to people in buildings, in and around buildings, is one of the major causes for the finding here. And so across the country and in California, buildings are now the #1 culprit for premature death from air pollution. And this is the way that we quickly as possible get it out into the atmosphere. You know, we burn it in our water heaters, we burn it in our furnaces, and then we quickly vent it out. And there's a technology, though, that burns gas in our homes, and unfortunately, we don't do a good job of venting out, and those are our stoves. And so significant amount of research coming out right now, but in particular, the team at Lawrence Berkeley Labs, Dr. Brett Singer runs a 6-person team that looks at the air quality impacts of different fuel choice and how you cook your meals. And in 2014, they did a study that modeled 60,000 homes in Southern California. And what they found is that for a significant amount, about half the households modeled, they expected to be finding illegal levels of NOx, carbon monoxide, and formaldehyde in those homes coming from cooking with gas stoves. Dr. Brett Singer said about the study, you know, if we were finding these levels outdoor, we'd be able to take regulatory action against the source of these emissions. But because these emissions are in people's kitchens, there's nothing that we can do about it. And so out of that, LBNL says there's probably about 12 million Californians with gas stoves that are breathing illegal levels of NO2, carbon dioxide, and formaldehyde. And it's a particular issue in our low-income households because we've only required ventilation over stoves since 2008 in California. And a lot of our older building stock that does not have ventilation over these stoves, a lot of our lower income communities live in those sorts of units and those sorts of homes. And so in smaller spaces, it's one thing if you live in a 5,000 square foot home and you can disperse the pollutants pretty easy, but if you're living in a small apartment without ventilation, it's a real serious issue. And this is not my inflammatory title to this slide. This is actually the title of a study where the data on the screen comes from. It's Cooking with Gas Can Harm Children, and it's put out by a group called Mothers Out Front. And it's a group of mothers who also happen to be health professionals, national group based out of Boston. And they looked at 250 different epidemiological studies of the impact on asthma rates of children that grew up in homes with gas. And what they found is that children living in a home with a gas cooking stove have a significant increased risk of current asthma, as well as lifetime risk of asthma directly correlated to the gas stove in their homes. Besides air quality, also gas is starting to really lose its shine as a real climate hero that we've held it up as during the Obama years. Last year, the very end of last year, new research came out about the leading causes of greenhouse gas emissions growth, and natural gas is now the #1 biggest driver of emissions growth globally over the last few years. And so we're going to have to get a handle on natural gas if we're going to get a handle on climate change. And in California, it plays a really significant role because buildings, from an end use perspective, where is the energy being used? From an end use perspective, gas is helping buildings really become the second largest contributor to greenhouse gas emissions in the state. And this is a chart that looks at end use emissions, and the building sector all the way over on the left side you see is a combination of the blue is the 75% of the electricity in the state that goes to power buildings that we're going to be all getting to carbon neutral by 2045 or sooner. The orange is natural gas emissions, and the gray is refrigerant emission losses. And so you can see that as we're going to get rid of the blue as we completely eliminate emissions from the power sector, and we're going to be left with that big orange block with a little bit of the gray there. And so we need to get a handle on that orange block if we're going to get a handle on our climate and our clean air policies. And one of the challenges for us is that we don't produce a lot of the natural gas that we use. We actually import the vast majority of the gas that we use. And what that means is that our strong environmental policies around air quality and our strong environmental policies around petroleum and natural gas extraction and the water quality and what you do with hydraulic fracturing pollutants don't really have a lot of effect on Oklahoma. Don't have a lot of effect on Texas and the practices they use, and then they ship that gas over to us. So what we're doing is we're in effect exporting the impact of these drilling and storage practices to other communities rather than our own, and we use it here in California. And what we're finding is that the very cost of infrastructure is having an impact on the cost of housing in California and nationally. We're obviously in a housing crisis in California. We need to be looking for every dollar that we can save. And if you look at the choice to putting gas to a home, and it is a choice because you can go all electric, as we'll talk about in a second. It costs anywhere from $6,000 to $15,000. This comes from PUC filings as well as some of our members that build homes in California. Depending on the size of the house and the layout, anywhere from $750 to $2,400 to plumb that gas around to the appliances, and then say about $270 to $850 to get those emissions into the environment as quickly as possible. The National Association of Home Builders every year puts out a report that looks at the impact of every additional $1,000 of cost on the average family's ability to be able to buy an average priced home within 350 major metropolitan areas in all 50 states. And so if you just take the low range, say it's only $7,000 to build with gas for all that piece, and then you look at these numbers, the choice to build with gas is pricing just over 1 million families out of the ability to be able to afford a house, and that's 1 million families more that we could afford to buy a house if we built all electric instead. We're also finding that gas is starting to lose some of its shine as the clearly more affordable energy source. Gas prices have been going up at just under 5% a year last decade, whereas electricity prices only about 1.4% a year. And Southern California Gas Company was just approved for a 25% revenue increase from 2018 to 2021, and PG&E a 26% rate increase for gas distribution. SoCal Gas asked for a 45% rate increase over that same time period, and the PUC cut them back to 25. Now, to be fair, the impact of the wildfires on electricity costs were something we're going to have to watch, but gas prices clearly going up at a higher clip, and largely it's due to safety measures and being able to actually maintain a safe gas system. And we're seeing that nationally too. Gas distribution system costs have tripled in the last decade, and we're paying over $15 billion a year right now just on distribution costs, not even the commodity themselves. And so what we're really facing here is we're starting to see a scenario where you have rising gas rates, the combination of policies and affordable electrification taking customers off of the gas system, which means there's a smaller amount of customers to pay for those fixed costs of the gas system, and therefore the gas industry, the gas companies need to raise rates, which then those higher gas rates make building electrification even more economic, and it makes it even easier for local and state governments to adopt policies. And you start to have a downward spiral of the gas system, where the only people left on the gas system are the people that can't afford to get off, or renters that have no agency over their appliance choice, and restaurants. So gas, what we're finding is, it's the fastest growing climate pollutant, the leading cause of premature death from air pollution. It is expanding fracking, exporting pollution to other communities, and raising the price of homes. And so the alternative really is to use all this renewable energy and these RPSs that are springing up all over the country, instead with really highly efficient technologies, heat pump technology and induction technology, instead to be able to build homes and retrofit homes to use these technologies and this clean electricity instead. And I probably don't need to explain what a heat pump is to this crowd, but it's basically magic. It's the same technology as in your refrigerator. It uses a condenser and a refrigerant to transfer heat from one area to another. And because instead of creating the heat, it's transferring it, it's incredibly efficient, about 3 to 4 times more effective, more efficient than the best-in-class gas alternative to that same technology. The big hangup is, of course, cooking. And so, magnetic induction cooking is really going to be the answer here. You can get it for about the same price as a gas stove. The lower range gas stoves are about $500. The lowest range induction stove of quality is about $900, and then they all ramp up over time. The biggest issue really, a lot of chefs use it, but the biggest issue that comes up for cooks, whether like gas stoves versus electric stoves, is really power and control are the two. And so SMUD did a study with the Food Service Technology Center, and they looked at this issue of power and control. And what they found is that induction was clearly better. They tested 3 induction ranges represented by the red lines here, 2 gas-resistant ranges represented by the green lines, and then a gas stove represented by the blue line. And what this is time across the horizontal axis, the time that it takes a stove to be able to heat 12 pounds of water up to a boiling point, 200 degrees, right here is represented by the dashed line. And you can see that the inductions were about 2 times faster than the electric and 3 times faster than the gas. And then the time that it takes you to take that boiling water back down to below boiling point. You can see significant amount of resistance and overshoot in the electric, and then because of the gas grill with the latent heat in them, significant overshoot for the gas as well, whereas with amazing control in the induction. So the 2 issues that cooks, whether you're a home cook or a professional chef, you're most concerned about is control and power. Induction really blows away gas and other electric. And Consumer Reports absolutely loves induction. They just released their top 8 ranges for 2020. The top 2 were induction. 5 of the top 8 were induction. The top gas one came in at $3,000 compared to the other induction units, which range from $2,500 down to about $1,000. So induction's fantastic. Electric buildings, clearly cheaper, more equitable, healthier, more climate friendly, and safer. And that's why not only Berkeley, but also 60 communities in whole are now in the process of adopting policies similar to Berkeley's, including City of Sacramento and West Sacramento, which I know are going through their own machinations right now. But what you have here is you have most of the Bay Area, LA City, LA County, all of Silicon Valley, Sacramento, all moving forward with policies to be able to start to limit natural gas or completely eliminate natural gas expansion within their communities. And this is Darren from PG&E, the manager of local government affairs for PG&E, testifying at the Berkeley City Council meeting. PG&E is, of course, the 4th largest distributor of natural gas in the country. And Darren stood up at the Berkeley City Council meeting and says, we support Berkeley and any other city that wants to help us stop the expansion of our natural gas network. It doesn't fit in the future of California's climate policy, and we can't afford to maintain it into the future. And they've been testifying at any city council meeting that they're invited to about these policies. And so I'll just skip through here, but it's happening in New York, New Jersey, Maine, Massachusetts, Seattle, and then all over Europe as well is starting to make this push. So in short, because of the factors you see up here on the screen, it makes no sense to build with gas anymore, except for tradition. Why would you want to build with gas once you know what you know up there on the screen? There is no reason, and we need to start the transition off of this. And so I'm excited by the actions of the PUC and the Energy Commission to start this transition. So if you want to work with us, want any more information on this, feel free to check us out, buildingdecarb.org. Thank you to CleanStart for having me, and I'm happy to use the remaining minute and a half for any questions you have.
Well, it may be more than a minute and a half. But you've given me some hope. I thought at this point I would have to pry my wife's gas stove away from her, only from her cold, dead hand. But I'll see if I can't get her to use one of those demonstration induction systems. So that gives me some hope on that.
I was talking to Drew Bohan, the executive director of the Energy Commission today, and he said that he used the SMUD rebate in order to get a stove, and he was blown away. And the ridiculous factor that you can't find a place to try an induction stove in all of Sacramento before you buy it, but he still blind faith adopted it. He said, it's incredible. It's a better cooking experience. Yeah, well, it's like every piece of it. It's power, it's speed, it's easy to clean. It doesn't make my kitchen hot in the summer. It's perfect.
Yeah, there must be an improvement in that technology. I have used induction systems before, and they are nothing like what you described. So I guess I need to update my reality.
I wanted to highlight, SMUD does have subsidies for residential and businesses that want to move towards electrification. And I'd also highlight that the CEC is looking heavily at using a lot of their EPIC funding towards building electrification and actually funding buildings to get built. That'll be kind of these futuristic buildings, much like if you remember at Cleantech Meetups, the Living Building Challenge that ArchNexus has built. There's going to be a lot of heavy investment in making sure that people and builders know about the technologies out there. Like Panama just mentioned, someone couldn't find a place to test this. Well, if you're a builder and you're trying to build this entire, housing block, you got to find out what are these new efficient technologies and how can you understand how they can fit into what you're building. So there's the CEC funding the building. There's additional funding that will be coming through Cal Testbed so that they can test all the technologies and demo that they work as part of the whole goal of turning California into this giant clean tech incubation from Cal Seed to Cal Testbed with EPIC funding. Unfortunately, there was a fund to help finance some of this and adoption of it through the CEC, but that's one of the funding things that recently got cut.
Oh.
Yeah.
Does PG&E have any incentives for electrification?
They're building some out right now. Right now they have electric to electric, but they're building some out. They just got approved to do water heaters and space conditioners and induction, and so they're building out the programs right now. So not just yet, unless you're replacing electric to electric.
Yeah, well, I think there probably still is a lot of information that's going to have to get to the professional chefs on induction, because that is really interesting new information.
All right.
Yeah,
We
here's
are.
some right here.
Will you be able to
So,
share your slides with us, Panama?
Yeah, absolutely. And just
Yeah.
on that last point, I know we're at time, but this is the French Laundry. This is
Oh,
Wolfgang
okay.
Puck. This is Guy Ferrari. This is Cafe Pacelli in Santa Barbara. This is the Great British Bake Off. There are major chefs that do love this. It'll be a major transition for the food service industry, but there are major chefs that we can point to that are using it.
That's fantastic. I'm going to show this slide to my wife.
All right.
Yeah.
Well, we're going to thank you very much for that. We're going to leave it kind of open for networking, but I want to do some wrap up real quick. First, I want to thank our sponsors again, Sac State College of Engineering and Computer Science, SMUD, Blue Tech Valley, and Weintraub Tobin. They're the leaders of the Cleantech Meetup, and they enable us to put this on and continue putting this on, and we're very grateful for it. Quick look back at our announcements. In the time that we did the presentation, Laura was able to put a link for Pacific Fleet Charging so that you can go sign up and come to that CleanStart to do. Also, if you want to learn about SMUD Go Electric, these are hyperlinked, so you can go and find out all about it. Perfect that you brought it up. Then moving on from there, I also want to additionally thank our other sponsors, EY, Stoller Reeves, Moss Adams, and Hacker Lab. And I want to encourage people to connect. I put some other places that you can connect with here. ChicoStart, AgStart are part of our network, and they're very important to turning Sacramento into a clean tech hub. And if you want to learn more about that CEC funding towards building and innovation, go and click on this one here, and you can check out Empower Innovation, which is where it's a network for checking out CEC funding opportunities. You can come and say hi to us there.
So Dennis Dahlquist has put up a nice URL for the pros and cons of buying an induction stove or cooktop. I would also just add a pitch here to watch Dick Flask's to-do on his system for replacing very inefficient theatrical lighting with high efficiency focused LEDs. We learned a new word in that to-do, attendu, and I think we have that one up. But you know, it's worth listening to because it's a market I never knew much about, and Dick's done a good job of explaining how he's going about it and beyond theatrical lighting, where his technology applies. So we've got a lot of stuff going on. Tell your friends about us and be sure to join our future programs.
We'll link to the videos that we have here. Yeah. All right, and that, I believe, concludes everything. Welcome to stay around and chat. I see David. Good to see you again. Haven't seen you for a while with all the safe social distancing. Yeah, do you have any questions for any of the presenters? I'm going to go back to one of the ones that Krista asked that I thought was a good question. And this is for Farid. What lessons did you learn from JLM that you've applied to improving Simpl?
Farid may have left.
All right. Okay. Well, all of these technologies are important in something called distributive power. Whether it's putting in charging stations throughout a city, or whether it is the battery management that Farid was talking about. And I know SMUD is really pushing towards electrification for being able to control its demand. Does anyone from SMUD want to chime in on that? We are at the 7 o'clock, so just pushing the discussion.
Well, and be sure and join our discussion with Guy Hall tomorrow on the implications of some of the new battery breakthroughs for electric vehicles and other things that are going on in electric vehicles. So it's our Between Two Nerds series as Thomas and I interview various people around the region. I think that's at 9:30 tomorrow.
At 10 o'clock.
10 o'clock.
Mhm.
Well, yeah, that's going to be live then, and then it'll be videoed and available.
Mhm. All right.
Okay. Thank you all.
Thank you. Okay.
Fun.
Tom.
Share.